Good afternoon, everyone, and welcome to E2E Networks webinar on AI versus Human Insight in Financial Analysis by Misho from ASX. I am Tanya, and I'll be your host for today. This webinar is brought to you by E2E Networks Limited, a mighty empaneled AI-first hyperscaler from India. Let me now take a moment to introduce you to our speaker for today, Misho. Misho is part of Clearing Risk Product Coverage team at ASX, has over 14 years of experience in data science and quantitative roles at top financial institutions like London Stock Exchange Group and Deutsche Bank. He specializes in developing AI NLP tools for document discovery and predictive analytics with extensive work in sentiment analysis and high-frequency data predictions. Now on to the main event. Misho, over to you now.
Thank you, Tanya, and thank you everyone for joining, and thanks to E2E Networks for having me. As Tanya mentioned, I'm very excited to talk to you today about how AI and humans can do financial analysis. It's based on an article that I've posted recently on Medium, and some analysis that I've done myself. First of all, before I start, I do need to do a few disclaimers. I work for the ASX Limited, but what I'm going to be talking about today is based on my views and my research and does not represent ASX. And then the other disclaimer is that I have two small children who may or may not at some point jump into the room. My wife is looking after them, so I think they're not, but this is something that can happen. Now, having said that, Annie already introduced me a bit. I come from like about 14, 15 years experience of quantitative risk and data science, product management. I used to work at Deutsche Bank in Berlin and then London. Then I was a data scientist at Cognitive Scale, which was a startup by a bunch of IBM Watson scientists and the general manager of IBM Watson. Then I've worked at LSEG, where I've worked a lot on developing systems around, ways that we can analyze news and text and research, improving search capabilities for the Workspace platform, which is sort of the Refinitiv flagship product. Refinitiv is a company that used to be part of Thomson Reuters, then became acquired by LSEG. And now I'm working at ASX in clearing risk. I've spent many years, trying to understand how we can analyze financial documents, news, research, and so on. And this is a topic that's really kind of close to my heart, because on the one hand, I find language fascinating and how people can express, different things in different nuances, and how they can express sort of, different, like the range from concerns to excitement and so on. In connection to financial analysis is also even more interesting because there's an extra layer when companies talk about their performance in earnings calls and corporate calls. There's an extra layer of complexity there where the management cannot necessarily disclose too much, but at the same time they need to disclose enough to present an accurate picture of what the state of their company. So in this piece of research, we've tried to sort of juxtapose what you can see in a news article reporting directly after an earnings call, and what you can see in an earnings call, and try to ask some of the large language models what they think is the most important. I've tried to match those things and see how well they are in understanding what is important in a financial context. This is an interesting topic for several reasons. Obviously, if we can do this at scale, right now, for example, just a thing on the NASDAQ, there's something like 4,000 companies. There's obviously all the major exchanges in the world, and including India, they have massive amounts of documents, and people like equity analysts or journalists, they can't really cover everything. In this analysis, I've looked at 8 companies, and they were like very major companies, but it was a bit difficult to actually match a good number of earnings calls with a news anchor. What I've tried to do is to look at, that overlap of something written by a human specifically in response to an earnings call and like what the actual full text of the earnings call is about. So why earnings calls? Like the kind of the best source of news about a company and its financial standing would be the earnings report and earnings statements. But they do have a lot of standardized text and standardized statements and disclaimers that you need to make. So that makes that text a bit noisy in the sense that there's a lot of disclaimers. But then on the other hand, it also kind of a bit standardized in terms of what can be said. There's a special area in earnings reports where management can make more discussion, give more discussion. It's called in the management notes, but still that tends to follow a standardized script. Whereas earnings calls is where actually the management comes in front of stakeholders and and analysts and tries to describe in their own way, in their best work, in the best possible way, what is happening with the company. So it's kind of as close to what they can tell us directly as possible. While we could get even more kind of extreme on the other side and kind of look at things like the general presentations that they make or any sort of announcements that they do, but those don't need to be very grounded in facts, and they can always kind of focus on any number of ideas. If you've probably seen some of the things that, let's say, somebody like Tim Cook would do, would make, or NVIDIA, Jensen would do, like they can talk very freely when they talk directly to a wider audience about all sorts of ideas that they have, but it's not necessarily linked to the performance of the company. So earnings call provide like an interesting sort of mix in between, where there's a bit of exposure to the general public, and at the same time, it needs to be grounded with like actual facts and direction and very kind of strict things that they're looking for. And in that context, what's very interesting here is that then you have also the analysts who can like freely ask and question things, and very often like they would ask exactly the most interesting things. I was reading an earnings call recently, one of the latest, I think, from Apple, and one of the like in many cases there would be things like Apple would be saying, well, we are slowing down. Apple might be saying something like, we are showing very good results across all areas, all of our products, iPhones, iPads, Macs. And then analysts would say, well, actually, that is not exactly what represents kind of the state of, like, there's very few people who own the latest iPhones that have, for example, AI capabilities in them. So it's that sort of challenges that analysts offer, and that's kind of the mix that would help ideally understand that. Now, the thing that I've looked at is, journalists having essentially that piece of document at that time when that was released, how did they evaluate that? And one very kind of important sort of statistic, I mean, I don't have exact numbers, but like I did some analysis some time back, and there's a good number of maybe almost 70% of the cases where there's a major stock market moves around, like, price moves around the stock that happen as a result of an earnings announcement and an earnings call, just because that is when the company is releasing all of the information that is crucial and that is very factual to the state of the company. So that makes them very interesting and makes them kind of drive the majority of the market, of the price movements around a company. So now going to going into how we analyze them, like what they look like, they are essentially, just a long piece of text. It's well structured in terms of if you deal with like large language models and text and analytics and natural language processing, it is a little bit of structure in terms of you can understand like what are the parts where the company is presenting, which are generally very structured and very kind of organized, and pretty much just kind of talk in words what is in the earnings report. And then the question answering parts where the actual analysts. Here's an example of like an analyst asking a question around Anheuser-Busch and kind of a specific accounting effect that Anheuser-Busch has experienced with regards to like their business in Argentina, and the fact that extreme inflation in Argentina may be distorting the way that the accounting of the company should work ideally, and like what it means for their like growth projections. So obviously growth projections are some of the major things that analysts look at in terms of how much earnings will a company be looking to get. So anything that directly influences that, and especially there's a nuanced kind of influence like that, would be extremely important. In the main body of this specific transcript, the company sort of like just briefly touched on it and didn't go into a lot of detail. The analysts then like dug into that. And then also the journalist reporting off the back of that was also looking into that specific example and said like, this is something that is important for the earnings. But it was very difficult for the large language model to actually identify that, yes, this is indeed something that is important. Why is that? So generally speaking, there's a number of like valuation things that the valuation drivers that we could look at in a transcript and any information about a company, and they fall into a bunch of categories. Here I'm showing a piece of analysis that we did as part of a product back at LSEG called Sentimine, where we try to identify specific sentiments from the text around specific topics. And we identified a list of about 100 plus topics. The paper is linked that are very crucial for the valuation drivers of a company, and also very often discussed in transcripts. And then you see, for example, in transcripts, in earning code transcripts, things like revenue, M&A, EBITDA, R&D, net income, these are things that come up like all the time and are the majority of what is driving. And if you look at this, a lot of this is essentially very much revenue related. R&D is essentially something that can be driving a lot of costs. If you're doing a lot of R&D, then potentially you're driving a lot of costs. You need to be linking it directly to potential revenue that you're driving. If you're doing a lot of M&A, that is very often some sort of upfront investment that you did to acquire a company. That again means that you've potentially spent a lot of cash. It also might mean that you, as a company, would need to understand a lot. You would need to potentially invest more in how to merge these two new businesses or whatever you've acquired, plus however your company is doing. This could be synergies that like a lot of things are overlapping. But it's a big question of like, are you doing this too quickly or too slowly? Both of them could be good or bad. So that's why these things come up in transcript. It's a bit different in equity research reports, but that's a different story. So going into this specific piece of research of what am I trying to do? I was trying to understand, thinking about the things that I mentioned, the different parameters that are important to a company, things like revenue and earnings and so on. Looking at those and then putting them side by side with what the journalists have pointed out, and trying to kind of instruct a large language model as much as possible to take those things into account, and then try to like pick up that from a transcript and see whether or not that can work. So I assume a good number of you have been dealing with like a case like that, where you want to test something. You have a hypothesis and you want to structure a problem. So I think I always find it very fascinating how to actually structure a problem like that. Because one of the main things is you want to have a metric that you want to evaluate, whether or not this works well or bad. And you want to understand exactly what you're testing with that metric, how that metric works, if it kind of actually fits the thing that you're trying to measure. In this specific case, I was trying to understand whether or not I can do at scale what journalists are doing specifically for the headlines that I've picked up. So I have to find companies where I know that fairly reliable journalists have done work on them. So I looked at publications like Bloomberg or Reuters or Barron's, and looked at whether or not they have what are the recent earnings report they've written about. And as I mentioned, there's a very small number of companies that they cover in a report like that, because it is very time consuming. The transcript itself and these calls themselves are about an hour, sometimes an hour and a half for each company. The actual a typical transcript is sort of equivalent to about 15 to 20 pages of text. And then on top of that, this is very often linked to the actual earnings report, which you may also need to learn and read and understand to actually contextualize. And on top of that, you need to potentially also understand what has happened to the company previously. I think I have an example later. It's with Salesforce, for example, they have they have had a lot of news around AI and AI acquisitions that they've made. And obviously, when they're talking about, at the time, this was done in sort of May 20, this year in May, and a lot of these earnings report were in March and April. So, at the time, everybody's talking about AI. So Salesforce were also talking about AI a lot, but that was not really new for them. They've been talking about AI for a long time. So kind of that understanding as a journalist, as a research analyst of what is where has the company been and where is it going and so on. So it's very time consuming to do that. So you need to find that match, and there's not a lot. Now, if you can scale that, that's very valuable. So then the way that we can manage that, the way we can build an experiment around that is by matching, these news with the transcripts. And then after that, see whether or not obviously the full transcript would be relevant, and whether or not then basically kind of how we actually evaluate it. So I've asked the LLMs to provide the 3 bullet points that they find most relevant from a news article, and the 3 bullet points that are most relevant from the transcript. And then obviously, as a lot of you know, working with large language models requires a lot of prompt engineering. So I did a bit of prompt engineering. I tried to test a few very standard, the most common examples of prompts. So I had think step by step. I had chain of thought, which is essentially kind of this it is think step by step, which essentially says, hey, think step by step and explain to me how you're going to think about it, and then do the result. But you can also provide sort of a list of what things to look at for that. So different types of prompts, and then finally, compare and match these 3. And that was again sort of I've used LLM as a judge, because with 8 news articles, and so with 8 companies and 3 and top 3 results from the article and from the transcript, and I've tested I think 5 large language models. It's many things to actually evaluate. So you want to use LLM as a judge. And that's kind of the experiment. So now you have matching of 3 examples and 3 kind of top suggestions from news article, and 3 most important things that the LLM thinks are the most important thing from the transcript. And you're trying to match them and see how often do they overlap. With that, you can then build a score. This is the final score basically that I got with that. I've tested things like, Claude Opus, Claude 3, Claude Sonnet, GPT-4, and Mistral. I had Gemini as well, but at the time when I was doing this, it was kind of a time between, there was Gemini 1 and there was Gemini 1.5. And I think Google was doing actually a lot of releases around that time. So I found the results of Gemini kind of going sort of back and forth a lot. So I wasn't really sure if they're actually changing the model a lot as I was writing it. So it was a bit difficult to actually rely on a specific result from Gemini. So I dropped Gemini. So what did the results tell us? So the best thing, so this score that you see, first of all, is basically how many of these 3 results have been accurate. So we have 8 companies, just for your context, it's mentioned in the article if you're interested, but basically the companies are Anheuser-Busch, as I mentioned, Salesforce, DocuSign, Snowflake, and like, you know, a couple of those. Like, so I didn't want to do like the biggest ones. I didn't want to just do Google and Apple and Tesla because they are anyway the most reported on. And I think that LLMs already have a lot of knowledge about them. But at the same time, I needed to have something that is like fairly like well recognized and well documented, because otherwise it wouldn't be in the news. So it is kind of names that we all know, but they're not kind of like the three companies that we all talk about all the time, which is, you know, Apple, Tesla, and NVIDIA. And so these results basically kind of showed that like the best result that I got was with GPT-4 and in chain of thought and kind of including a previous transcript. You see S by S, which is like step by step. So the difference here between COT, chain of thought, and S by S, if you see my mouse, kind of the 80% is the COT. Chain of thought would be essentially kind of is a case where I've actually provided it with a list of steps to follow and to think. So I can actually give it an instruction, you know, for financial analysis, here's the things that are important. And these are largely the things that you saw in the previous slide before, when we're talking about look at revenues, look at earnings, look at other things that might be influential but may not always be there. So we're talking about mergers and acquisitions, R&D, regulatory risks, cybersecurity, other risks, and so on. So outside of the revenue bucket and the costs bucket, then there's like a big long list of things that are maybe that if they come up in the transcript, they could be very good or very bad. So kind of give it a bit like I've given it a list that, and that is this chain of thought. So what was interesting here is that, first of all, these results were not very stable. And when you read this chart, you should imagine that like around all of this, there's like a bit of a fuzzy plus minus 5% around all of these numbers, because by repeating the experiment, I was getting always slightly different results, because the large language model would pick some things as important, and then like if you run it again, it will pick slightly different things. So these also averaged out of 3 separate runs for each of these models. So on top of everything, like we have all the different models, the 6 types of prompting, which is naive prompting, just kind of giving it a transcript and asking for a result. Chain of thought, where you give it specific steps that are based on sort of financial knowledge and financial expertise. Step by step, where you rely on the model kind of trying to figure it out on its own, just by telling like think step by step, and then expecting it to figure out itself and will write an instruction. There's a term of like a scratch pad. So I gave it a scratch pad where it can like write down, here's the steps that I think I want to follow. And then that generally has also proven to improve a lot of these results. What you're not seeing here, obviously, is agents. I didn't get to agents here and kind of knowledge graphs and so on, but I'm going to talk a little bit about that. And so one thing to notice is that I found very interesting in this analysis, and bear in mind, it is a small sample, so still 8 companies and so on, but I did rerun it, 3 times and saw that like it kind of tended to converge around these numbers. So it's not completely like up and down. It is a range of plus minus 5%. One thing that I found interesting is that actually outside of GPT, chain of thought and step by step didn't necessarily kind of improve the results for the others. Right? If you look at naive prompting, Claude actually performs pretty well, and even here with chain of thought, like it kind of Mistral kind of performed well. But then adding these things that we would otherwise from like common knowledge think about, that adding more information, like adding an extra transcript, would help. They didn't actually help the models that much. And sort of having chain of thought, for example, like confused, Claude 3. So it kind of reduced this result. It reduced the other Claude 3 result. Oh no, this one kind of goes up a little bit, but not significantly. And here actually, so Claude Sonnet perform better if I just tell it to figure it out itself without actually giving it specific steps. So the interesting thing here was that these are kind of common sense things where I would have expected when I put this chart kind of left to right, things would generally go up as I give them more context, more transcripts here, as I give them more, step by step and more instructions. Like I would have thought that, okay, chain of thought, if chain of thought works better here, for example, for the Claude models, then if I also give it chain of thought and on top of that, give it the whole previous transcript, that would help somehow. But no, it actually kind of didn't really help at all, whereas it seemed to have helped GPT a lot. The reason, by the way, that the previous transcript is relevant is because in financial analysis, a lot of what people do is kind of comparisons against the industry and comparisons against like the previous, where were you before and where were you now? Does that actually, like, are you showing kind of an improvement or a deterioration? So the previous transcript might have pointed out some things that were happening or certain directions. So generally, it would help. It would be that context that I mentioned that it helps to see what other things the company has been talking about. So why these designs and choices? So here I had the companies. I mentioned a little bit about the companies. Not necessarily like the biggest names, but kind of known names. I mentioned that Renault experienced 3 times to get an average. Different results had as much as 10% difference in performance, but like kind of overall it was like plus minus 5%. In some cases up to 10%. And then I mentioned the different prompts that I had. And then I talked a lot about like why earnings call transcripts. Yeah. So what was kind of difficult for the models was understanding exactly these changes. So it was interesting that with Nordstrom there was a case where, for example, they were showing muted revenue and demand expectations in 24, but that like actually pushed the Q4 2023 results in terms of importance. So like there was this, like if you think back to the slide that I had about all the different drivers, everything about revenue and performance and EBITDA and so on is important. But when you're talking about, okay, my future actually is not that promising, like 2024 is not as promising as we thought, that obviously is less important than Q4 results. So what the models tended to do is they did tend to figure out, okay, we need to talk about revenue, and when we talk about revenue or change in revenue, that there's more revenue in Q4 than before, that's good. But then they kind of got confused about, well, actually, how do you stack up that in terms of importance? There's obviously hallucinations and things like that where the models couldn't exactly, like, we're kind of coming up with things which are not necessarily in the text. And they were missing significant one-off events. So there were, as I mentioned, that example with the Argentina inflation, for example, was missed in many cases. I think in older models, even though the journalists pointed it out and the analysts were asking questions about it, and the analysts, like, that information of what the analysts are asking was also provided to the LLM, just like the journalists. Like the journalists would see these questions by analysts. So it, like, in some cases it missed significant one-off events, in other cases it didn't. But the challenge with these things is that in a transcript, as I mentioned, the company would generally be talking in a very positive voice about everything. They wouldn't be kind of saying, hey, we had this big problem. Or if they say we had this big problem, they would only say it if actually the stories and then everything improved. They would kind of mention things, but kind of mention them in passing or put a positive spin on them, which is why just a model, even with the instruction of, be careful about changes and be lookout for these things, still was confusing about that. And then kind of my kind of most interesting thing was the story around Salesforce and like their mention of AI, and the story around Snowflake, and the fact that both Snowflake and Salesforce had a lot of news about AI, and I think a lot of the models picked up news about AI. kind of a mentioning of AI, the journalists actually put a lot more focus on what Snowflake did, which was basically appoint a new CEO, which has a lot of background in AI and comes from Google, which is, you know, an actual action and a change to governance and a change in structure, and shows like a real direction in terms of AI and innovation for Snowflake, versus the fact that that Salesforce actually mentioned AI 91 times in their call, which is probably more than once every minute. So they mentioned it quite a lot, but like the journalists themselves didn't pay so much attention to it. And I think that has to do with the fact that Salesforce has had a lot of, you know, work together with AI. You know, they've acquired a lot of AI companies over the years. They've done a lot of things, but they didn't necessarily have any specific like big announcement or any big kind of thing similar to like on par with Snowflake. So the Snowflake reaction from journalists and so on was very positive about that like action, versus, you know, just mentioning AI a lot, where, you know, the AI is analyzing this discussion about AI, really likes to point out how innovation and AI are very important, and they're definitely kind of big news. Yeah, so that was kind of something that was challenging for the models. Yeah. So I wanted to just here point out a bit about like longer context and like the concept of needle in the haystack. This is a bit of an aside, but basically what I'm doing here in many cases is kind of a longer context, even though transcripts tend to be around the 20,000 tokens. Like the charts that you see here are like much longer. They go up to 120,000 tokens, and they're very outdated. Like this is like GPT-4, I think in November last year. So all of these things perform much better, but it's just important to kind of mention the importance of, when we consider this whole discussion around, you know, finding specific facts in a very big text, it is an ongoing thing that you should consider when building your models and experiments of where exactly is the information in the text, and the fact that different models might have different performance when you know, when the information is in different places in the text. As I mentioned, all these charts are very outdated now, but it's just, I want to like kind of more kind of show the framework of how people have thought about it and have analyzed things, because it helps for you when you're building a system like that, or an experiment like that, to kind of think in terms of that grid, and like, is my data in different places that I'm interested in, and just thinking about that might actually influence the importance in the results of what I've done, or where it is. And also since then, a lot of discussion around needle in the haystack has been that it kind of simplifies the problem, because it kind of creates a very clear metric of solving something, which then a lot of companies went and fixed and improved these metrics. But that doesn't necessarily mean that more complex things like, you know, multi-needle or actual like reasoning based on different pieces of information. So a piece of information might be in the beginning of the document, and, you know, some other like response might be somewhat further down in the document. That may not like be anywhere close to that. You know, kind of the parallel to my results here is that, you know, that's like the test that I've done requires that sort of reasoning to kind of look at the whole document, in some cases look at the previous transcript, and kind of make connections about, you know, what was happening here, what was happening there, is this a change, is this a significant change, what is important about the company. So that piece is very difficult to measure, and is something to consider, which is why kind of my results were not, like you see here, mostly 100%. With some exceptions, my results were mostly like, you know, 60, 70%. This is kind of a more detailed picture about like some examples, and also to give you a sense of what like the actual analysis looked like, and what the actual kind of content looked like. When I say come up with like 3 important things, this is what the actual data looked kind of in the end ended up looking like. These are the different companies, and, you know, on the news side, I would like the LLM would pick up 3 important things, and on the transcript side, the different LLMs would pick up 3 important things, and then they would compare them. Naturally, I kind of like looked at the results from the news ones because these were quite important to actually measure everything against. And this kind of bottom part is what I was actually evaluating. And here again, I've asked the LLM to, like, on top of everything else, again, summarize everything in 2 or 3 words. Again, a very useful technique, I think, if you're trying to do something like that, because really the bullet point is like 2 or 3 sentences. So this kind of helps you spot a little bit what sort of results there are and what you're looking at. And for example, here on the CRM side, which is Salesforce, you see how, like, very often there are things that are mentioning, data cloud, innovation, and so on, whereas the news articles have focused on revenue projections, operating margin, dividend, and buyback, kind of boring things. Whereas asking the model, what is important, you would, like, almost all of them almost always said, yeah, that's, there's AI stuff happening, which makes sense if you look at, the document as a piece of, bread. Like most of the material that was making it up was talking about AI. AI was mentioned 90 times, but when humans analyzed that, they paid less attention to the AI part. So yeah. And then also here on the other side, as I mentioned, Snowflake, the mention of the new CEO and AI focus, and the fact that here on the flip side, kind of the mention of the new CEO was kind of mentioned in the beginning of the transcript, and like from that point on, it was just there. Like, we know that's the CEO, so a human would look at that and say, like, whoa, there's like a new CEO. And the AI would say, well, we're not saying that 25 times anymore. Like, this is clearly not important. So yeah, that's that one. And kind of my final slide, just kind of what are additional directions. As I mentioned, there's not a lot about RAGs and agents that are done here, and there's not a lot around graph-based analytics like GraphRag. It's kind of mandatory these days, these couple of weeks, to talk about GraphRag, so I wanted to put it there. It's a nice picture. But like, how does it relate to this? So, like, in a RAG and an agent kind of context, you would like have more of that iteration that we saw that like really chain of thought boosted the results of the performance for the model. So you could have seen something similar with like in an agent framework, where it might be asking itself questions and see, okay, can I summarize, like, what are the important questions? Based on those questions, what can I find out, like, about them? Can I compare them to the previous transcript? So an agent that can, like, talk to itself and, like, challenge itself can have obviously better performance in that. And then graph-based sort of analysis, things like transcripts and any financial topic are extremely heavy on numbers and entities and their relationships. So, especially something like GraphRag, with more work on it, in the current state, it's kind of still like an awesome tool in and of itself, but like with more work layered on top of it, it can help toward sort of summarizing text like that. One of the key things about how GraphRag works is that it provides that ability of like creating these sort of communities within the knowledge graph, which means that, like, unlike most kind of knowledge graph solutions out there, GraphRag would, in addition to just kind of give you nodes and connections, would actually tell you, hey, all of these kind of belong together. So if we say that this like pink area here is essentially something about revenue, you can, and you want to like assess, hey, is there something important about revenue? What GraphRag does is it then goes to this area and says, hey, tell me just in this area what is important about revenue. Whereas if you don't have a graph or anything like that, you would just inspect the entire document, and then you have just like a smaller chance to understand that entire document and like find exactly that information. Then if you just know, okay, so this area is the revenue area, and in that area I can ask a question specifically about that and kind of derive that. and like another thing that I mentioned about generally transcripts and financial analysis, a lot of it is based on changes from one period to the next. So when you overlay a transcript with the ability to specifically identify entities like topics and companies and products and entities, you can then analyze what are the changes between those entities from one period to the next, as opposed to just kind of asking the model and giving it, 50,000 tokens and telling it, hey, tell me some things about stuff, right? So yeah, I mean, that's kind of future directions that this can expand into and that it can grow into. Yeah, it was a fun little project, and a combination of a lot of other work. And I'm still kind of actively in my spare time working on analyzing deeper these transcripts. Yeah.
So I think we have a question here. No, it's just a feedback. Great presentation. Is it possible to take your research and code and then further contribute to it?
Yeah, I mean, the code is, the code itself is a bit messy, and I didn't mention that. I might talk about code, but fundamentally, there's nothing too complex around the code. There's just like the loop that would add, it's not even LangChain. It's just sending those data to the models, like asking them the different prompts, the different ways in which you can, like, the different sort of things about the transcript. And then just the evaluation around it, which is nothing more than just comparing these. The one thing to mention is that there is like a separate, like the second layer is essentially that thing of transcript, kind of, here's a bunch of answers from the news article, and here's a bunch of answers from the transcript. Compare these three and kind of tell me how many match, and you kind of do sort of function call on that one, and you say, just respond, match, doesn't match, and so on. So that produces you kind of a table that you can analyze, and then you just have then the third piece is just pretty much an evaluation, which just says, put those in a table, calculate some averages and so on. There's some sort of diagnostic statistics that you might come up with, which will be very different depending on how exactly you look at it. So if you're looking at data from, so there were some things like, for example, some of the models might not be able to produce 3 responses, or they would produce more responses, and so you might have some sort of diagnostics around that of like, are they producing the right shape of an answer? I think specifically with Gemini, I think it was kind of evolving a lot around the time when I was writing it, and like initially it was difficult to get it to produce in like a normal function call, so that was kind of something along those lines. But yeah, it's the reason I haven't made the code publicly available is, number one, it is not more complicated than that, and number two, when I release something, I want it to be documented and broken down and so on. Nitin, if you have, or anybody else, if you have specific questions around that, we can talk about that more offline. But there's nothing I don't want to share code that is fully documented, not readable, not understandable, and so on. And it's nothing more than that, really.
Yeah, we have another question. Have you tried fine-tuning model for financial use case? When is it apt to fine-tune for customer use case, given the effort?
So I've done some fine tuning. It depends on the use case, not for this specific use case, but we have done some fine tuning for specifically around understanding topics and semantics and identifying topics and so on. I would always approach it as first do whatever you think is the best model right now. So I did this back in May, and all of these models are outdated now. So right now I'm just very actively using GPT-4o and Claude 3.5. I would just first go, even though they're paid models, like start with small experiments with the paid models to understand like how, or like kind of whatever are the best models, like they might be open source, whatever the best models to kind of see how well this is going, and then validate really that the use case needs to go further. And like where I kind of end up at that stage very often is that you kind of want to match it with what is necessary. And in some cases, kind of very often, like at that stage, you're probably good enough, or you kind of identify that there is a specific area where you want to drill into, and like kind of you want to do that. So the sequence I would follow is always start with the ready models and do as much prompt engineering there. Then go one level down into like open source models, and then do fine tuning. And then that kind of ends up with like fine tuning being kind of much more rarely used in practice. Only when you're beyond the POC and you're like really implementing something, and you really want to get that difference from, let's say, being 80% accurate to being like 85% accurate. That's kind of how I see it, or like 90% to 95% accurate. I think the bigger challenge that I found is like to make everybody be on board with the fact that we're talking about systems that are that are solving specific problems, and they are going to be like 80, 85%, 90% accurate. When we did the sentiment analysis, we actually gave it to humans to evaluate, and the humans themselves agreed with each other about 85 to 90% of the time. So our users were, our kind of stakeholders were like, it needs to be 100% accurate. And then we're like, but the humans only agree with each other like 85% of the time. So how do you want the system to be 100% accurate? So it's really kind of looking at that differential in terms of like, when do you want to do that? Because fine tuning is just a way to like have a never ending sort of project. Because you can always argue, you can add more examples and train more, and you can refine the data, and the data that you created for the model is not good enough, so like revise the data and I'll fine tune again. It's kind of an endless circle. So as much as you can, avoid it, and use it when you've exhausted all other things. I would say. Another thing, kind of, sorry, in specific in financial context, it's important that a lot of these models are about facts and specific things. Fine tuning helps you understand semantics better. So I think that's a very important thing of distinguishing: is your problem with fact identification, or is your problem with semantic understanding? So if you have a problem where you can't, for example, you want to ask the model that it just tells you things from the last 6 months, that's not really a fine-tuning problem. That's a problem that you add more metadata to your RAG system, so that you can somehow, guide it to say only answer from the last 6 months of data, don't answer from the last 20 years of data. That's not a fine-tuning problem. So like, it could be other directions. Whereas if it doesn't understand the semantics between what KYC and KCP means, like that's kind of the fine-tuning finance type of problem.
Yeah, one last question is there. Same prompt generates different results. How do you decide which prompt result is accurate and you need to go with it? Is there any supervisor model?
Right. So the same prompt does produce different results. I think part of it is the nature of the problem, but I think it is also like very documented that these models are not consistent in the results that they're producing. So what I've done in this case is when I look at like in this case, I've just been looking at the problem. I'm looking at the results in kind of a very kind of conscious way of this. If I share again, look at this. You don't look at this chart anymore of just looking at what's the highest value. You look at this chart as what's the high, like when are the values more than 5% away from each other? And I've tried to only highlight these values that are really more than 5% away from each other. Like, I can't really make a statement about what's the difference here, for example, between the 3 Opus and Sonnet and GPT-4. I can't really say which one of these is really different because the plus minus, like you kind of think about it in terms of like this little cloud of thing. Now I can definitely say that like, Mistral has an issue here. Mistral has definitely gone down because it's gone down by an order, like kind of by 10% down. Like, so something is going on there. I do think that Mistral is just either overwhelmed by the extra information, has some sort of, needle in a haystack kind of problem, or that just like our assumption about how prompting works for something like GPT is different than how it would work for something like Mistral. But that's just because there's a massive gap. You can't interpret these like small results. And then, yes, you can have a supervisor model, of course, as well. In this case, kind of the supervisor model was the fact that in the end, I was just asking GPT-4 to kind of tell me which one is which.
A heartfelt thank you to you, Misho, for this insightful session, and big round of applause for all of you who have joined us today and participated so actively. Before you leave, we are eager to hear your feedback on today's session. Please take a moment to fill our quick NPS survey. Your response are incredibly valuable and will help us improve our future webinars. While you fill the poll, let me give you an introduction to what we do at E2E Networks. E2E Network Limited is leading AI-first hyperscaler from India, focusing on providing advanced cloud GPU infrastructure. We lead the industry as prominent cloud GPU provider, offering comprehensive range of NVIDIA GPUs, including HTX H100, A100, L40S, L4, A40, V100, and T4s. To know more about us, you can check out our website, e2enetworks.com, or if you want to get your hands on one of our GPUs, you can sign up at myaccount.e2enetworks.com. I'll be posting both the links in the chat box for your reference. Thank you, everyone. That's all from us today at E2E Networks. We hope you found this webinar valuable. Stay tuned for more such events from E2E Networks. Have a wonderful day ahead.